second. My pen is not working. Let's get that fixed real quick and see if that helps a little bit. And maybe not. Alright. Okay, here we go. Be sure to include today's date, students, with your notes. The heading again is Circumference and Arc Length of Circles, Lesson 11.5. Be sure to include today's date. Now, let's start off with a quick review of what circumference means and also what the formula is when you're finding the circumference of a circle, okay? Pretty elementary, and really literally, I mean elementary, it's like elementary school or middle school, but let's just make sure no one's confused and make sure everyone understands this, okay? If I ask you to find the circumference of a circle, I'm asking you to find the perimeter, the distance around the circle. In other words, if you were to take this circle, take a pair of scissors and pretend this is a rubber band, and take a pair of scissors and cut the rubber band and lay the rubber band out flat, the distance from here to here would be the perimeter, okay? So it's the distance around the circle. Now the formula you use, there's actually two, so it's your choice. You can use 2 pi r, which is a good choice, or pi d, which is a good choice, okay? So either one of those two formulas will help you find the circumference of a circle, okay? Now, having said that, let me go ahead and throw a problem at you real quick, then we'll finish up with a more difficult problem, and then we'll be finished today. It's a pretty short video, okay? Did not mean to click that. Alright, let's quickly find the circumference of a circle if its radius is 5 inches, okay? So here we go. Let's go ahead and draw a little circle here. You don't have to draw a circle unless you want to, it's up to you. Radius is 5. So let's find the circumference, and we're going to do it two different ways. We're going to first of all use 2 pi r, and then we're going to use pi d, okay? So here we go. Let's find the distance or the perimeter or the circumference around this circle, alright? So for 2, I'm going to put 2. Unless I say otherwise, we're going to use 3.14 for pi. And then radius, well, the radius is 5, so we'll put a 5 here. So with my calculator, 2 times 3.14 times 5 would give me 31.4 inches. Now, that's not square. That's not the area. That's the perimeter or the circumference, so we just say inches. So now you know the distance from here to here. If you have a circular swimming pool in your backyard and you would put a privacy fence around it, you would find the perimeter around the deck or around the pool so that you would know how much fencing you would need. Now over here, you can also use pi d like I told you up here. So for pi, I'm going to put 3.14. And for d, I'm going to put what? Well, if your radius is 5, then your whole diameter all the way across is 10. So 3.14 times 10 also gives you 31.4 inches, okay? So either one of these two formulas work. That's pretty basic math, but I still want to make sure you guys know how to do this. Again, circumference is the distance around a circle. You can use either one of these two formulas, and pretty simple, okay? Now, let's move on to something more difficult. What if I were to section off part of a circle like I have done below in red, and I asked you to find the length of that arc? Could you do that? Right now you could not, okay? Because you don't know what the central angle is. The angle that formed this arc, you don't know what the angle is, nor do you know the length of the radius. Thus, you don't know what portion or percentage of the circle is sectioned off, okay? You have to know the angle and the radius or the diameter, either one, to be able to figure this out, okay? So having said that, and I would copy this circle in your notes, guys, because we're going to use this in just a second. Having said that, however, now that I'm telling you the central angle is 100 degrees and the radius is 4, you can find the length of this arc from here to here pretty easily. Here's the arc right here. Let's say it was a rubber band again. You could stretch it out and make it straight. If you made it straight, the length from here to here would be the length of the arc, and that's what I'm going to find, okay? So let's think about this for a second, students. First of all, let's go ahead and find the circumference of the whole circle. from here all the way around back to that green dot, okay? Let's find the circumference. So here we go. Circumference is 2 pi r. 2 pi r. So 2 times 3.14 times the radius, which is 4. Or you could use pi d, of course, and that would work just fine. So if you take 2 times 3.14 times 4, you will get 25.12. So I know the total perimeter, or the total distance around this circle, is 25.12. Now, think about this, guys. How can I find what percentage of this circle is sectioned off? Well, I have 100 degrees, do I not? 100 degrees is what part of an entire circle? Well, an entire circle is 360 degrees. So what part is 100 degrees? Watch this, please. I put 100 over 360. That makes sense, guys, because the whole circle is 360 degrees, and I'm taking part of that. I'm taking 100 degrees of the 360. So I'm going to write it like this. Now reduce it. Reduce by 10, and then reduce by 2, and you'll get 5/18. So what percentage of this total circumference from here to here is being sectioned off? Well, if this angle is 5/18 of the whole circle, then that means this arc length also has to be 5/18 of the entire circle. Now, what is the entire circle from here all the way around the entire circle? Now, please don't say 360 degrees. Yes, when you're dealing with degrees from here to here, that's 360. Now I'm talking about the circumference, the distance around the circle. From here all the way around, the entire distance around the circle is 25.12. So I want 5/18 of that. So I take my total circumference, or my total perimeter, times the fraction that I'm dealing with. If you like formulas, total times the fraction, and the fraction is what? 5/18. So with your calculator, most of you have a fraction button on your calculators. 25.12 times 5/18 is going to give you 6.977, 6.98. So the length of the arc, I'm going to change colors here, the length of the arc from here to here is 6.98. We're going to put units because I never labeled my 4. Now, if my 4 was feet, then this would be feet. If it was inches, this would be inches. If it was centimeters, then this would be centimeters, okay? But it's not squared because it's not area. So there we go. Isn't that easy, students? If you know the total circumference and you know what fraction this arc is, then multiply the two together and you'll have the actual arc length, okay? So not too bad. Okay, I did tell you this video would be short. Almost, actually, so far every single lesson in this chapter has been pretty short videos. Most of our focus is on the homework, so I hope this video has been a help to you. If